neural network is basically a approach of solving the unknown issues in terms of classification problem, forecasting problems, weather forecasting. It is a prediction. So, neural network can do the job of prediction. Like over the years, statistics have been corrected based on these inputs. What will be the cloud condition, all those things, neural network will forecast for you. So, there are many such applications, we will discuss that. So, each element is linked to the neighbors by a strength which is varying in strength, that is called weights. That flexibility is this, it is a connections where each connections have the option of varying values or strength, that is called weights. Okay. So, like electrical circuit, it is not required that only a particular connection should be made. You can have a varied connections between the different nodes, and that varying strength connections or link is called weights. Okay. And basically, that multiplying factor which we are doing before starting of the class, that multiplying factor is nothing but choosing of the right weights. So, that if that connection is made, if that wire is connected, you will get that required voltage V 1. The very good thing of this neural network is that you visualize as a current voltage nodes, apply the current nodes, get the required voltage, we say it is excitation potential or the firing potential. Unless you fire, next node cannot be driven. So, to get the firing potential, you need that much of voltage to be created there. How do you create? Your input is fixed, you are giving I 1. So, you have to choose that wire which will give that much of drop in that particular node. So, choosing of that wire is nothing but finding the right weights of the neural network, right multiplication factor for that particular input. Okay. So, this is a biological neural network which we are seeing now. There are some terms called dendrites. See where is the dendrites lies, this point is called dendrites. Then you have a cell body, the cell body has processing of loss and summation. Also this is a point where you are having all processings. So, the processing is done here, all right. Then you may have some bias, together it is called threshold. Once this threshold is crossed or it is reached, the firing takes place. So, you get the output, is not it. So, unless until you reach after this processing that threshold value or that value, it will not give you the output. So, once you reach that, it will give the output to the next. So, that is called the action as per this. So, now if you have kept this in mind, then let us go to the situation when we compare with the artificial connections. Prior to that, we had a term called the dendrites. What is this dendrites all about? This is here, just to give you some idea, because neural we are saying and we are going for a biological approach. So, let us have a look. This basically receive the signal from other neurons at connection point called synapses. So, basically the dendrites accept inputs, the dendrites accept inputs. This is usually no physical or electrical connection made to the synapses. This is biological point of view. Soma is the sum of all incoming signal or process of the input. Then we have the action, when a cell fires, it transmits the signal through action to the other cell. So, this is the output going from one cell to the another. Cell body generates the output neurons. So, all processing takes place in the cell body, all right. So, if that is the case, synapses is basically the elementary signal processing devices. It is a biochemical device which converts a pre-synaptic electrical signal into a chemical signal and into a post-synaptic electrical signal. So, basically in our body we have chemical and electrical both type of signals. So, that processing takes place through a synapses. So, again the input pulse strength has its amplitude modified by a parameter stored in the synapses. The nature of modification depends on type of synapses or the inhibitory or excitatory situation which you are using. So, basically the presynaptic postsynaptic approach is done through the synapses, all right, but it is not a pure physical connections which we are talking. So, therefore, the comparison when we do cell body, what does it do? All processing, that plus and summation sign or the integration sign which I kept, it was in the cell body. So, in our artificial neural network we say it is neurons. It does the plus and summation activities or integration activities. What is this dendrites? Dendrites are the words or the interconnections in our language. So, the words or the interconnection which are there, that is called dendrites. Soma is the net input which is applied to the neural network. Soma already net input, I told it sums in biological term also, it sums all inputs. Here it is all inputs, summing up all inputs is called soma. Then when you are getting the output, that link which is giving you the output is called the action. So, this is what is the way a biological model can be interlinked with the artificial model which we have right now here. Is that clear? So, not necessarily that you pick up all the terms, may not be required, you just pick up those terms which are electrically linked with those phenomena which is taking place inside the brain, and that is the terms which will be used for designing this neural network. Okay. This is again to give you some idea on this, so let us keep this part, then coming to the. So, out of this which one is the most important unit for you? It is the neuron, because all your processings are done in the neuron, that is a processor. So, therefore, in neural network neuron is a very important constituent. So, what are the parameters that characterize that particular constituent, that is neuron? So, the neuron is basically characterized by the architecture or the connection which you made. For example, you mark here one of this neuron is connected to only 2 nodes, input nodes. So, that means now this is driven by the parameters of the or interconnection of these 2 nodes. But if I put now this connection here, this behavior or this process will change, because now it is having the influence of 3 nodes and their interconnections. So, therefore, earlier the architecture was it is not fully connected input layer, because one of the input was not connected that time. So, if it is connected now, it is a fully connected approach. A fully connected and partial connected are 2 different architecture. So, therefore, we say that connection of the architecture that influence the characteristics of the neuron. Second, that training or learning. So, training and learning, they are used to determine the weights. What is that right weight? That should be linked with the input or the output layers, so that you get the required response. In addition to this, there is a very important term after this processing. This is doing the job of the summation, multiplication and summation. Now, after you sum it, let us say I give this example like this, it got a 3.4 volt, it got a 3.4 volt in one of the neuron node. But now you want a sinusoidal signal should come out of this. Your input which has come to this place giving you a voltage, but that signal you want as a sawtooth wave or a step function or a sinusoidal signal. How do you do that? Unless until you pass through a function, you cannot get that. So, this voltage, this value which you got, it has to pass through the shaping function, that shape which you are looking for, yes or no. So, that shaping functions, if I am looking for a sinusoidal signal and taking a shaping function which will give me a sawtooth one, that means that is the wrong selection of the shaping function. Sawtooth wave can be after many processing can give me a sinusoidal thing, but the processing the other additional component, other additional steps will be required. So, whatever is coming out, its accuracy, its getting the result achieved in a quicker time, all this depends on this function which we say activation function. So, in neural network this is another very important constituent, that right selection of the activation function, that mathematical function. I will discuss this activation function, it is called limiting function or squashing function, why it is limiting, squashing. Once we come to the activation function, we will discuss that. So, basically look here, this neurons which is the main processing unit of the artificial neural network, which has the equivalency with the cell body, is governed by three main aspects: architecture, which basically linked to the connections. Second, it is the training, what type of training you are doing. I gave you one example, telling only to this kid, showing him the picture book, showing him the video, all together 3, there will be a difference of training. If you just talk, may not work. Show him the picture, show him the video, all together mix it up, it will be all right. But when you mix it more, lot of things you will show him that he will learn, then it is called overtraining. Undertraining, overtraining are also to be avoided, that once training stage comes, we will discuss on those things. Complete the way a human being learns, this is the way the neural network also learns, we also follow the same trend. Is it okay? So, these are the 3 important parameters. Then comes the taxonomy. Generally in normal books they do not talk about the taxonomies, but you people remember this, because sometimes in interview board they ask what is the architecture of your neural network, what is the taxonomy of your neural network. You should be well distinguish between these things, your answer should distinguish very nicely on these two. Architecture, when we talk, it talks about the connections. It is nothing to do with how the data flow takes place, how the training takes place, or how it is trained. But when it is taxonomy, it talks about the data flow and the training approach. So, it has 2 things. Taxonomy is basically into categorized into 2. One is called active or decoding phase, active or decoding phase. This active and decoding phase shows how the data flows take place from one node to the another node. For example, in this case, if you see, if I go on putting the arrows like this, then the data is flowing forward, the data is flowing forward. But if I put one connection like this, then data is flowing backward. So, you have the option of, means there are neural network, when they give this input to this first layer of neuron, first hidden layer neuron, looking into the response, like it suppose this neuron requires a very high voltage to fire, for example I am saying, and you are giving a very low input excitation, then instead of processing this, the neurons returns it back. There are neural networks. So, it will tell that is not sufficient. So, either you change or you drop, other nodes let them drive me. So, there again you see the information flow is backward. So, how your data is flowing, whether it is a feed forward, getting feed forward, feedback, all those things is your decoding and active phase. Then the second is called learning or encoding phase. It is the learning and the encoding phase. You see, when you are making a person trained, you are encoding him, just link with that. When you are, like we are teaching you neural network now, I am basically encoding you, I am trying to put neural network in your mind, so that you learn something. So, if you ask as a machine language, I will tell I am encoding you on neural network now. But when I take you to the examination hall and put questions, then basically it is decoding. So, there if you are giving a feed forward answer, you are passing, if you are reversing it, you are not passing in that in a joking way anyhow, that is not the thing. Feed forward feedback, all those things are giving the data. It is a direction the data flow after the situations of learning takes place, that is the training phase. So, basically taxonomy deals with two things, encoding and decoding. Encoding is learning stage, decoding is the output when the response is coming out. So, when response is coming out, we say how the input data is going, whether it is going feed forward, whether it is going feedback, all those things. But you should not get confused with another term called the error back propagation. There we will come to learn about many algorithms which are learning algorithm. We say there is an algorithm called error back propagation. So, there you mark the word error is back propagated, whereas your data input data is feed forward. So, it is called feed forward error back propagation. So, specifically it is mentioned that error which you will get, that will be propagated backward to update your weights, update your links, so that you get the right result. Whereas, in this case when we are talking feed forward, feedback, that decoding phase, basically we are confined to the data set, how the data flows takes place. So, this is again to emphasize more on the concept which already I have explained. What is a partial connection, what is a fully connected? Fully connected means all your neurons, all your nodes available in the networks will be connected to each other. But if it is partial, like out of this 4, out of this 3, you are looking for a very, let us say kilovolt of situation output, but one of the node is millivolt. When you are using it, when you are going for the averaging, it is really not contributing, rather it is affecting your output. Do not use that. In a team, 5 people are supposed to work, out of 5 people, 1 person is not contributing anything. So, if you put your efficiency, your output will be divided by 5 average. So, because you are also, he is also counted and you are also taking his computational time, his salary, everything is counted in that. Then when your output is coming, it is output of 4 people. Okay. So, 4 people output being shared by 5 resources which are given. So, your averaging will be less. So, in that case the situation is that fire that man, either throw him out from the job, go with the 4 people, because you are getting the same output what you are supposed to get, or in that case you are not fully connecting, you are partially connecting. When you are fully connecting, everybody is contributing in that. So, depending on the contribution, then MLP, you see there is a word called MLP here. This is called multi-layer perceptron approach, means this is a situation you have multiple layers. You have first hidden layer, second hidden layer, like that multiple layers. So, the MLP is a multiple layer approach. There is a Jordan networks, neural network, fully connected, feedback network, feed forward network, like that. Depending on this, you will have multiple different type of neural networks. We will discuss this one after another later on. This is a first class, so we will go with this one. Then the learning is the stage where you are basically trying to adjust the required weights. Weights is unknown initially, weights is not known to you. If weights are known to you from the very beginning, then there is no hassle of designing the network or getting the network ready, because you are not sure what type of connection will give that firing potential there. You are trying with a arbitrary approach. What is this arbitrary approach? You randomly select, see what is the error you are getting, again change that, see what is the error you are getting. Accordingly, it goes on updating the connections or the weights, synaptic strength we say it is weights, and that weights when it reaches the required value, you stop there, okay, now it is trend. So, we go on teaching you for 4.5 months in a semester, then in December month we say appear for this examination, because you are now ready. Today if I say appear for your semester examination on neural network, it is you are not ready for that, I have not trained you for that. But today onwards, when we will be training you on neural network, after 4.5 months you cannot tell that I have not studied, I will not appear your exam. You are supposed to appear the examination to get the output. What is that? To get good marks or pass the MTech degree or ME degree. So, this training parameters is a situation, or the learning parameter is a situation to make the neural network ready for the response. Okay. The response, that unknown inputs which will be giving under the same class, like say I have 10 patients. Let us take the example of pathology, so that you can clearly understand this. The neural network which you have prepared, that neural network which you have designed, it is supposed to do the job of a pathologist. So, now to this neural network you have given the input set out of 15 patients. So, all the 15 patients data you have given, which is having a composition of malaria parasite, dengue, all those things, heterogeneous may be there or homogeneous pattern also you have done. Let us say malaria parasite you have trained him. Now, this 20th patient, 25th patient, those who are coming, they are unknown people, because only 1 to 15 are known patient. You are aware that they are having malaria parasite, and you train the neural network to see the difference between a normal blood sample and a malaria parasite samples. So, it has been trained that way, but when the 16th man came, about its pattern it was not given to the neural network. No information was forwarded to the neural network. So, it is an unknown pattern now. We do not know whether it is having the malaria parasite or not, we are testing it. So, when it is given to that, if there is malaria parasite, then there will be that similar type of patterns. So, neural network immediately will try to match whether there is a similar type of pattern or not, it will search. If it is there, it will tell yes, this man is also falling under this class for which I am trained. But if you have trained the neural network for malaria parasite and you are giving a dengue sample to test that, then it will not be in a position to test that, because he is not aware what is dengue sample. You have not trained him what is dengue sample, like I told you, that you have not trained a kid what is a zebra, and you take him to the horse, he will tell it is, it may, and you ask find out a zebra, then he will show it to the horse and tell it may be zebra. So, that type of situation may come. So, in that case the error will come, neural network will give you some response which will absolutely not match with this. It will not tell that I do not know, I will not train, like human being it will not tell that, it will give you some result, but it is not trained for that pattern, that data set. So, you have whatever training you are doing, this training is falling under a class. So, the class may be homogeneous, this class may be heterogeneous, like you mix up dengue sample, you mix up parasitic sample, you mix up the H1N sample or chikungunya sample. So, once it is trained, more or less he is knowing about the different patterns. Now, you give a patient who is having both malaria parasite and dengue, neural network will be in a position to find out yes, there is malaria parasite, because it will go on matching with the class which you have taught. So, whenever it is matching, it will tell yes, this one is present, all right. So, this is a very important phase of neural network, because the training and learning, if your training and learning is not good, then your performance in the examination also will not good. Like if you are in a department where you do not have experienced teachers to teach you, the freshers are teaching, there is every probability that the learning or training which you are getting out of them are not up to that level. Obviously, unless you do extra labor, with that knowledge if you go to the examination, then a person or a student who has come from a good institute having experienced teachers exposure, he will surpass you. So, the training and learning is a very important aspect of neural network, and there are certain rules. This is called rule based learning and training. You have been asked to come and attend class. You have not been asked that sit anywhere and just listen to me. It is not like that. You are also falling under a rule based learning. So, neural network also follows rule based learning. So, this rule based learnings will follow certain learning rules, training rules. So, those rules are to be taught to you. We will be teaching, either madam will teach or myself will teach that different learning rules. So, based on these learning rules, you will find that certain atmosphere or certain conditions, certain application, some rules will be well suited, some rules may not be well suited. For example, I want to give you industrial exposure to you. In a classroom, I cannot do that, unless until I take you to the industry to show you that industrial rule. So, if I teach you a classroom rule basis, ultimately what I will do? I will go for the slides, show you the industrial process. When I take you to the industry, you will get confused, everything is looking similar. So, which one, which sections, that problem comes. But if I take you there, show you that this is unit 1, this is unit 2, this is the interconnection, you will not get confused. So, the rule based systems are also applicable to our learning, same is the case with the neural network. So, it is also application dependent and particular rules. Again, in rules there are many parameters You take a textbook, you take e-journal, you take this, so that your learning or training will be faster, you will be learning more. So, here also accelerators are there, robustness has to be increased, noise factor, all those things in training phase it will come. We will discuss once we go to the learning and training phase, but try to correlate with the phenomena, so that you will understand this subject better way. So, when we talk about the training of the neurons, because neuron has to be trained now, this processing nodes, when it is passing through the training, there are three classes of training. One is called supervised training, another is called unsupervised training, third is called reinforcement training. All right. So, there are three major categories of training the neurons in a neural network. One is supervised training, another is unsupervised, third is your reinforcement training. Supervised, this is well self explanatory approach of training, that you are going through a MATLAB lab, whenever you are stuck, you are not getting the result, your teacher is there to tell you this syntax or this toolbox syntax which you have taken is not correct, take this one, you will get the result. So, you have using your brain, you have picked up something, but you are not getting the result. So, now the teacher is coming and telling you that this is the mistake which you are committing and rectify it. Yourself you are rectifying that, it is not the teacher who is sitting and rectifying it, only the teacher is giving you the feedback that you are not correct, this is the mistake which you are committing, correct yourself. This is a supervising approach. What is reinforcement? What is reinforcement in that situation? Okay, what is okay? Before I come to reinforcement, let us go to the second one. What is unsupervised? What is unsupervised? You people have done many times unsupervised learning. It is a fact. I am not joking. We will correlate with that. The subject should be related to the real life problem, so that always you will try to remember. Maybe in your DSP class, madam might have conducted your MATLAB, isn't it? She conducted MATLAB for you or not? Or Rajesh sir took your DSP class. So, there you see, when you are designing a DSP filter, this that through the MATLAB, when you face problem, your sir comes, this is what is the problem, you solve it, this is the way. The sampling frequency should be taken like this, cutoff is this, so this is the rate which you have to apply by linear transformation, you will get the result. That is a supervised approach. What is unsupervised approach? Obvious, means there is nobody to supervise your activities, but can you correlate with a unsupervised situation which you have encountered in your study? Unsupervised situation I will give you, that the networks learns from the input patterns, like you go on giving the inputs of the same class, then you are going to get outputs. For input 1 you are getting output, input 2 you are getting output, input 3 you are getting output. So, when you go on getting these outputs, then a pattern is generated, a knowledge is generated because of this. Now, a sixth input which comes and falls under the same category. So, whatever it is giving, if it is nearly matching with that pattern, then you say yes, fine, it is a right answer which I am getting. So, it is learning from the experience, learning from the previous experience. So, you have training data set, you are passing that, you do not know what will be the final output, because supervised case may you know the output and the feedback, the error is told to you, but in this case nobody is there to tell you whether you are doing whatever you are getting is correct or not. But let us say a young teacher does not know what is the answer of his questions which he has raised, while teaching in the class somebody has raised a question, he does not know that answer. Then what does he do in that case? He knows these 5 students are good, Ram you say, Shyam you say, Hari you say, like this. If all 5 are telling the similar answer, same answers, it taken as the answer for that class. So, his answer is told to him that this is the answer. If similar class question comes, so it is falling under that category, this answer is, so it is matching with this or nearly matching with this, so it is an answer. So, this is a situation like this. Is it clear? Chemistry lab you do, salt test you do, 5 category of salts are given to you, you go on testing, see the patterns. So, 5th category will be falling under this salt or not, that you classify based on this, is not it? You might have done that in +2 science also in your chemistry class. 5 salt, whether this salt falls under this category or not, you go on testing, when it is matching you say yes. There is no supervised approach here, it is an unsupervised approach, but you are taking again getting the right answer, because you know these type of characteristics, agar ye blue, red yes dikhega, then this may be the this type of salt. So, you decide based on this and you get answer, correct answer for that. What is reinforcement? Enforcement, reinforcement. These two class, like in books you will find mainly they discuss supervised and unsupervised approach, but reinforcement is basically an approach which is more important, especially when you are having uncertainty more, unknown parameters more. You are handling a problem which where you are not having very basic knowledge. You see unsupervised case, you are having the knowledge of the things. Supervised is a full fledged supervised situation with knowledge. Unsupervised is also with knowledge, because you are having the past experience of that. You are aware what was happening with this data. If similar class data comes, then what will happen? So, some knowledge you are having. So, it is also with knowledge. Remember this classification, sometime in class interview board it is asked whether it is with knowledge or not. It is with previous experience, so it is knowledge. Reinforcement is unknown completely, like you are sending a vehicle to the Mars. What is there in the Mars is not known, what is the parameters which will get changed there is not known. So, what does it do? After reaching there, it will try to match with the situations. So, learning from the environment itself without any past future past experience, it will try to learn from the environment, and based on this learning it will take a decisions, okay, this is what is the situation which is present here. So, this reinforcement is completely scenario where you basically do not handle with the known informations or the information which at least about which you are partially having certain knowledge. Reinforcement. Mars case, you take the unknown exploration space, we do not know, we are sending the vehicle, we saw something, what is that, nobody knows. Then once it goes there, collect data, analyze the data by itself, it takes a decision, this is what is present here. So, those type of situations are reinforcement learning. We will try to, and reinforcement approach, adaptive reinforcement approach is a good approach in the neural network now. People are trying, lot of activities are going on in this direction. So, reinforcement learning is to handle more uncertainty, more unknowns, and the situations where you are trying to find out the output response without knowing about the inputs, without knowing about the situations where the inputs are being handled. More or less other case it is known, either known directly or indirectly. Right. Reinforcement we say it is, enforcement is a class of that. So, we say it is a reinforcement approach, means putting ourselves in that enforcement situation, reinforcement. So, enforcement training is not there, it is reinforcement training, this is called reinforcement training. So, under the supervised training, these are the different class of neural network. We have feedback neural network, we have Boltzmann machine, mean field annealing, recurrent cascaded correlations, learning vector quantization, back propagation through time, real time recurrent learning. Many such are there, I have just listed a few, and which are commonly encountered and commonly asked questions. So, they are falling under the class of supervised. All right. Continuity of that, again Persistent, Adeline, Madeline, back propagation, ArtMap, cascaded correlations, they are different type of networks, and these networks are named based on the architectures, but the taxonomy follow or the learning approach follow is a supervised approach. Unsupervised learning matrix, driver reinforcement learning, counter propagation, they fall under this type of categories. So, as I told you, people basically classify the training approach into two broad. So, you will find either supervised or unsupervised. Reinforcement are very rare occasions where we use this terminology. This is the set of your unsupervised approach, ART1, ART2, Hopfield, bidirectional associative memory, temporal associative memory, Kohanen self-organizing map. You have some of these neural networks in your syllabus, you will be also reading specifically for this. So, these are all unsupervised approach neural network. So, when we say supervised, unsupervised, be clear that we are talking in terms of the training approach or learning approach. When we take the feedback network, these are basically the connection architecture which will be handling that data flow, all those things. So, this is again to give you some idea that inputs and outputs, how they are connected. Now, designing or developing a neural network. So, with this we will try to develop a neural networks, but when you pick up a neural network, as I told you, it is application dependent. So, depending on the applications, you have to develop the neural network. So, first is what is the choice of model? You have different choice of neural network. So, which model you will choose, that depends on the data and the applications, the data which you have and the applications which you are handling. Then once the model is chosen, like one particular model you are accepting, then what is the learning algorithm which you have to select? What is the learning algorithm which you will be selecting? Then comes the robustness, depends on the cost function or the activation functions. What type of activation, cost function are permissible, what you can use. In addition to this, we will come to the cost function choosing later on. Then in addition to this, the other bottlenecks are the computational processing thing, because as already I have told you, computer is a complementary resource for neural network approach. Without computer, you cannot think of a good neural network model, because all your processings are to be through a computational process. So, now therefore, you have to look for very important thing, what is the computational power. If you are having multi-layer situation, like so many hidden layer you are putting, so many neurons you are putting, your RAM is not supporting, your memory is not supporting. So, then in that case, you cannot really handle those type of model which or architecture which you have designed. So, therefore, looking into the computational power, like you are making a neural network which can run in a supercomputer, you have a supercomputer option. So, better go for that supercomputer approach. So, if you do not have a supercomputer, you are dealing with a desktop, you cannot handle a neural network model which you have designed, anticipating that you will get a computational power of supercomputer. So, that you have to keep in mind. What is the capacity? That how much memory it can accommodate. 10 neurons, each neurons will process, and neural network will not complete unless all the neurons that are available. It is not that only one node is processed and you have to wait. So, that storage, that particular iteration time, that one instant of time, so many storage will come. So, whether your computer is supporting that storage, otherwise there will be overflow error, all those things will come to picture. So, that is also to be taken care. Then the convergence. This is a tricky thing, there is no thumb rule where we can tell that it will converge after 500 iteration, it will converge after 10,000 iteration, we cannot tell that, there is absolutely, but convergence is a tricky thing, but convergence also has to be seen that how quickly your processor can lead to that convergence depending on your weight selection, approach of weight selections, this is there. Then the neural network model should be more generalized in nature. So, if we design a pathologist as neural network as pathologist, then it should not be like that only it will work for malaria, other sample it cannot detect. This should not be the approach. So, you should make it more generalized in nature, so that many of the applications, many of the similar applications or same pattern type of applications can be handled. So, that is why this is a term, and when we talk about the generalizations, as you know, it will depend on the term called statistical approach, because the statistic of dengue is not same as chikungunya, it is not same as the malaria parasite. So, therefore, it has to handle with a different type of statistics. So, that different type of statistic has to be handled, so that the neural network model which you are making as a generalized approach. I think I will just give a simple hints on activation function, because activation function, again different type of activation functions are part of the syllabus, it has to be taught as a separate class. So, before I close, let me just tell you how do we process and what is the importance of this activation function. This is the neural network which we have, this is the output layer. So, what basically it does, you may have also external bias to this, like these are all interconnected situation, you may have also a bias, you may also have a bias. Okay. So, then what will happen now? Already I have told you that imagine that this is a current node passing through the links which we say resistance, it is offering some resistance, then obviously we will have a voltage develop across this node. So, as the voltages are getting developed, one from this, one from this, one from this. So, you will have the voltage, how it will be dropped? You have a connection, let us say it is R1, this is R2, this is R3. Then what will happen first? R1 will multiply it with I1 plus I2 will multiply with R2, then you will have R3 multiply with R3 in 3 for node 1, all right. Together this is, let us say, the voltage which we create is V1, plus there is a external bias which is also giving a voltage. So, with this bias, let us say it is giving B. So, if I add these to B, then that becomes the capital V1 which I am getting here, all right. That is the net voltage which is now generated in that node, and it is ready for fire, and this is called the firing voltage. But this voltage, this phenomena, if you see what we are doing, we are processing this with time. We say iteration now. Before starting up this class, which exercise I asked you to do, what we are doing? We are basically processing with the time. In first instant we are getting result, or second instant we are getting third instant. Time is a infinite process. So, if you go on processing this, there is no stopping for it, it will go on repeating its behavior, because time is a infinite process. So, you want to stop, a infinite process has to be stopped. So, there has to be a finite discontinuity to that, and that discontinuity should give you the output which should not have much error, not acceptable type of situation, all right. So, therefore, you need a squashing functions or a shaping function, so that it stops after a certain times, giving the shape, giving the output which you are looking for, and you stop the iteration there. Okay. So, therefore, this voltage which is generated now, it goes through a function, this f, all right. So, this function is very important, because without this function you cannot achieve the finite value, you cannot achieve this shape. So, therefore, it is also called a limiting function, it is also called a squashing function, and it is also called the activation function, all right. In many name it is told. So, if you see here, the output which you are getting as y is a function of the voltage which is generated due to the bias and the voltage contributed by all input nodes, all other connected nodes. So, that is the voltage which is coming from the connected nodes, this is the bias, together is the net voltage V, it is passing through a function which is called activation function, that will give us the output y. So, the output y which is now, suppose here in this case, so what is basically coming f of V2, this is what is the output which will come to this. Then output is also a neuron, remember this, this is what is the situation which will be to be kept in your mind. This one is a simple node where you give the input, it does not have a neural approach to it, but when you come to the output, we say it is a output neurons. So, output neurons also will have an activation function. So, whatever you are getting in this, it will come to this neuron as V, its potential. Then depending on the function here, it will give you the output. So, if it is a identity function, whatever comes that will come out, that becomes your output, all right. So, when you are reaching the output nodes, remember that that is a neurons, it has to pass through that type of situation, that multiplication, summation and the activation function approach, all right. Now, these connections are to be defined, you do not define in terms of R1, R2 here, we say that weights. Okay. In neural network language, we say it is weight, and the input we do not say I, generally the convention is input is written as x, because already it is a statistical signal processing model we are talking. In signal processing, what do we do? Generally x is considered as input, y is considered as the output. Here also the x set, when you say x matrix, when you say, that is input set. When you say see this y set, or when we say y set, means it is output. Now, this x and output, when we talk, so this I 1 will be replaced by x, x 1, x 2, x 3, like that. Is that clear? The R 1, because why I am correlating this, so that always when you talk x, keep in your mind it is current. Whenever you are talking W, you keep in your mind it is R. So, you are looking for that V, so that you can correlate with the network model, all right. So, x has to have a weight. So, this is W, we write, let us say this is W. This W, there are many W, how to classify that? So, Chandigarh से बस अगर दिल्ली जाता है, what do you say it is? The Delhi bus is going, isn't it? उसको तो चंडीगढ़ का बस नहीं बोलते ना, you say a Delhi bus is going, दिल्ली जाना है तो उसमें उठ जाओ. So, if a bus is going towards, let us say Kurukshetra, you say it is a bus to Kurukshetra. So, destination comes first, destination comes first. So, to specify this, to specify that how this W is different, how R 1 is different from R 2, what we do? If I remove is in terms of W, now I have to specify that, because this is also W, this is also W, everybody will be W. So, my destination is which node? Node 1. So, it comes as first. From which node it is starting, from Chandigarh or from Ambala? It is starting from Chandigarh, that is 1. Similarly, if I go to this connection, this R 2 has to be replaced now. My destination is 1, because going to Delhi starting from Ambala. So, it is 2. This is the way you should follow to write your weight value. Input as it is 1, if you are taking, take 1. So, it is 1 2 1 1 like this. So, generally what we do, we define in terms of I and j. We put this as I, this as j, j will vary, how many weights will be there here? You see, how many nodes are here? 4. How many nodes are here? 3. If it is fully connected, 4 into 3, 12 connections will be there, because each will be have 4 connections. Each node will have 3 connections, sorry. Then there are 4 nodes, so 12 connections. So, your j, that means 12 connection means 12 weights. So, j will vary from 1 to 12, isn't it? There will be 12 weights. So, j will vary from 1 to 12, whereas your I will vary, that input will vary from 1 to 3 only, because there are 3 nodes. So, this we will discuss in next class, the connection and how these connections are multiplied. So, activation functions individually has to be discussed, which activation function is good, why it is used, under what circumstances it is utilized, all those things are a separate class we will discuss, but these connections, this weight, how the suffix are decided, conceptually you must clear your doubt. You should not have any doubt on these issues, because ultimately this will turn towards your the final goal. Okay. So, then next class we will start this activation function approach.